The AGV path is holding steady at Sector 4.
Confirmed. Trajectory remains optimal for the starboard billets.
Check the microstructure at grid reference C-4.
Confirmed. The automated scan flagged a subsurface anomaly here.
A specialized industrial scanner performs a full volumetric assessment of the alloy billet. It uses CT.
Based on the quality control data, the arm labels the billets. Blue indicates process A for the wing pylons, while red is reserved for the internal wing spars.
As the A-10 is stress tested, these titanium steel billets for internal wing spars undergo a specialized chemical bath, ensuring
Integral to Process A, the controlled heating and quenching cycles achieve the final required hardness for armament carriage.
The pylon is rapidly submerged into a specialized polymer quenching bath. This precise quench rate locks in the crystalline.
The structurally certified A-10C pylon undergoes final critical boring. The tolerance is measured in microns.
In this close-up, infrared lamps accelerate the curing process on the A-10C wing pylons, ensuring consistent material properties and efficiency.
Check.
The conclusion of Process A. The wing pylon stress testing is complete, and the machinery is in standby mode. Transitioning from stress test A, we move into iterative process B.
Known as shot peening, this process introduces beneficial compressive residual stress onto the titanium steel surface,
Process B, high cycle fatigue test sequence initiated. Monitoring all parameters.
The thermal camera captures the critical joint undergoing fatigue testing. Minute temperature fluctuation.
The finished 3-meter internal wing spar is automatically wrapped in specialized VCI protective film.
The VCI wrapped 3-meter A-10C spar undergoes final crating.
With stress testing complete, the experimental A-10C wing spar begins the logistics phase of Process B, moving towards final assembly.
Secure that hardpoint. We need full tension on the binders.
Copy that. Running the winch now. All secure, Supervisor.
Transporting the A-10C wing spar is the first phase of real-world stress testing, moving it from the controlled environment to the utilization phase.
Verification complete on the A-10C internal wing spar. Process B documentation is accurate.
Acknowledged. Shipment accepted into inventory.
The spar looks pristine. Process B was successful.
Confirmed. Ready for integration.
We have green on all points.
Perfect alignment to clamp. Secure the clamps.
With the final panel secured, the internal wing spar transitions from an individual component to a vital part of the A-10C airframe.
The completed A-10C wing, utilizing the new internal spar and Process B, is now ready for the fuselage mating station.
The completed A-10C wing section is aligned and matted to the central fuselage.
Ensure the primary flight display is seated correctly.
Harness secured. Moving to the stick check.
The final rollout of the A-10C Thunderbolt II. The new digital camouflage is ready for operational testing.
Check the leading edge. Hardpoint stress gauges, red-green. Spars look solid.
As the Thunderbolt accelerates, the robust internal wing spars endure immense stress, a critical phase of the testing.
The A-10C undergoes rigorous low-altitude stress testing, but thanks to advanced manufacturing in Process B, Process G,
The reinforced titanium spars are the result of Process B, guaranteeing the structural integrity required for the next mission.